The first law of thermodynamics is the basis for another assumption of the pneumatic compressors, the isentropic compression assumption, and a variant of it can explain the principle of compressors. The essence of the first law of thermodynamics is that energy is conserved. If two different systems are taken as example, in the ideal state, the thermal energy of one system is converted to the thermal energy and kinetic energy of other system. For every system, the expression for the first law of thermodynamics holds. For system 1, the internal energy is from 500 kJ to 0. Since all the heat energy is released, it is the negative number. And system 1 is to make the object of the system 2 do work, so the W of system 1 is a positive number. For the system 2, the internal energy is changed from 0 to 500 kJ, because most of the heat energy is absorbed by system 2, and small parts of the work is done on the object, so the W of the system 2 is a negative number. The following are some variations of the first law of thermodynamics. In fact, the system can only do work by expansion or contraction. If the volume remains unchanged, there will be no part that does work, only the mutual conversion of the internal energy and thermal energy. This process called isovolumetric process. If the temperature of the system is controlled, the system does not transfer heat, so all changes in internal energy are related to work, a process called isothermal process. If the system cannot transfer heat, the change in internal energy is only related to the work done. The compressor is based on this principle, and this process is called adiabatic process. If the system neither transfers heat nor does work, then the system has no internal energy and remains constant. This phenomenon is called isolated state.